Okay, so for the task number 2, okay, again we start with opening a new window. Okay, and you go to save as, okay, to your folder and save as the task number 2. Okay, okay, let me just close this. Okay, so the task number 2 will be about using the for loop. Okay, so what we do here is we want to calculate the charge from this equation. So this equation is about discharging a capacitor. So your charge will be exponentially decay or exponentially decreasing when the time has passed. Okay, so if you get more time, yeah, you will have the smaller and smaller value of the Q. Okay, so again we are starting with importing the library NumPy. Import NumPy as np. Okay, and then if we specify some of the parameters, okay, so if we are given the capacitance as 200 microfarad, so if it's a 200 microfarad, you can just type down 200, and micro is 10 to the minus 6. That's okay. So here I will just comment that this is the capacitance of 200 microfarad. Okay, and then R, or the resistance, we use the resistance of 300 kilo ohm, or just 300,000 ohm, and we use V0 as the 10 volt. Okay, so actually I just used these parameters can be any. I just used the thing that I have from the first year lab. Okay. Okay, so now we want to use the for loop command to vary the time. Okay. Okay, so here before we do before we do it, I will introduce you to the command called range. Okay, so now let's go to the console window. So if you type range like this, and then you assign any number into the range. For example, I input the range 10. So the program will give you a list. Okay, so this so this format, so this type of variable, and in Python we call this a list, or it is simply a set of numbers. Yeah. So this is, so range 10 will give you the number from 0 to 9, so integers from 0 to 9. Okay, so it is, so it just means that you start from 0 and you stop with any number that is less than 10. Okay, so the other way around, if you type range 0, 10, it will give you just the same thing here. And if you type down like range 310, it will start from 3. If you type 320, it will start from 3, but it will stop at the 19. Okay, so here's how it works. So here, if we use the for loop command to vary the time, for example, if I say that for I in range 0 to 10, okay, and then I say that the t, or the time, is 50 times I. Okay, so if I do like this, and if I print out the t, so what we expect the program to do is it will be running, it will be computing the value t and print out many times. Okay, and when it does computing for the first time, it will use the value of I as the 0, or the 0 is actually the first value within this range list. Okay, and then for the next loop, it will just do 1, 2, 3, 4, 5 until 9. Okay, so here I'm showing what we should get from this loop. Okay, so the things that we get is the first loop, we get the 0 because it is 50 times 0, and for the next loop we get 50 because it's 50 times 1. Yeah, and for the next one we get 100 because it's 50 times 2. Yeah, so here, this is how it works. And then after that, if we want to calculate the charge, yeah, of course we can do that. Okay, so we will just do Q equal C times V0. So if you look at this equation, the Q0 or the charge, or the full charge, yeah, you can in the capacitor you can calculate from capacitance times the voltage. So it's Q equals CV, and then we want to type down the exponential term here. So how to use the exponential in Python? You can use the numpy again. So we do the np.exp. So it's numpy exponential, and within the exponential we do the minus t over RC. Okay, so it would be the minus t divided by R times C. Okay, and then we could try to print the Q value down here. Okay, so run the program, and here you got the value of Q printed here. Okay. It might not look so beautiful, so again we will try to print these things out as a format. So then we do the print, and in the quote sign. Okay, so you could try something like Q. So this will be printing just the Q. Okay. Yeah, this will be printing just the Q for all the way through. So if I do like this, so Q, so bracket, and then now if I do percent 8.3f, so this means we are printing the float with 3 decimal numbers. Okay, and then we are printing. So here we are printing the time. So I would say that, okay, we are printing the time. So this is what you have. Okay, so you have Q 0, 50, 100, 100, 150. So this is the time. Okay, so we are printing Q as a function of time, right? This is what we say. And I would say after this seconds, yeah, it depends on you, and then equals to, here I would say percent 8.3 E. Okay, so I will reprinting the value of Q. Yeah. So in the unit of coulomb. Okay, so then in this bracket, so after the T that we are printing here. So this value T will correspond to this format. So for the formatting text here, we need another number. We need we need the actual value of Q variable. Okay. So with this, if you run the program, it will just show you the same result, okay, but in a good format, in a scientific number with three digits. So here you are printing the calculated charge in the unit of coulomb, okay. So you can do it. You can do it is a little bit further, okay. So what if you want to print your number out as in the unit of microcoulomb. Okay, so here I would try adding the percent 8.3 F, and then another number that corresponding to the format. Yeah. So if I have this, if I have the charge value in the unit of coulomb, so if I want to get the nanocoulomb, yeah, I should get the microcoulomb. Yeah. I should get this value Q divided by 1 times 10 to the minus 6. Yeah. So here I should get the value of charge in the microcoulomb unit. Okay? So here this is the end of the task 2. Yeah. We can calculate the charge as a function of time and in the microcoulomb unit.